Hi, in this video we want to look at unit vector. That is what we want to look at. In my earlier video we looked at scalar and vector quantity. So I advise you look at that video so that you understand more about scalar and vector quantity. So we are looking at unit vector. What is unit vector? A unit vector is a vector of unit magnitude with no unit. So a vector whose magnitude is equal to 1 is a unit vector. So we say a unit vector is a vector of unit magnitude with no unit. And the main purpose of a unit vector is to show us direction, to point to direction. And normally, we always use a caret or a hat to represent unit vector. So if this is a unit vector, this is how we represent it. So we have three symbols that we use as a unit vector. You have I with caret. So these are unit vector. We shall be looking at it as we make progress in this class. So unit vector I and j can be represented in Cartesian coordinate as you have unit vector j in y-axis and unit vector I in x-axis. So if this is the origin, we can represent unit vector in Cartesian coordinate as this. So we have that vector A, which is equal to ax in, we can write in s axis as this, s component. Then in the case of y component, we can write this way. Okay, this x supposed to be I, then this y. So we can write vector A in terms of component unit vector. So the ax, ay, they are scalar quantity. So if we have unit vector, we can represent as xi plus yj. So if this is a unit vector A, we can represent it this way. So this is how we write. So if this is vector y and this is vector x. So this is how we represent unit vector. And in the case of, if we want to represent including the one for space, that is the unit vector in terms of I, j, and k. We can write it this way. This j, unit vector j, unit vector x, and in terms of direction z. So these are all unit vector. This one pointing in z direction, in x, and in y. So this is another way we can represent unit vector. So we are saying that unit vector I and j can be represented in this way. So if you have vector A in terms of the x component, in terms of the y component, so the vector A can be written as vector A equal to axi plus ayj. And like I said earlier, the ax, ay, they are scalar quantity. And we can increase this to write vector A to be equal to ai unit vector A, ay unit vector J, plus az unit vector K. So this is how we write vector in terms of component, vector component. This is how we express vector in terms of the component. Okay, so from here, let's look at how we will find the magnitude of a vector using the component. Magnitude of vector, magnitude of vector from the idea of the vector component. So if vector A is equal to ax unit vector in x component, ay in y component, and az in z component, as we just demonstrate here, then the magnitude of the vector will be equal to ax squared plus ay squared plus az squared. So please, if you forget everything, you don't forget this. So to determine the magnitude of a vector, you take the square of each component and the square root. So this is how we go about it. So let's look at an example. Let's look at an example of how we find the magnitude of vector using the component. So example, given two displacement A equal to 2I plus 4J minus K, all in meter, and vector B equal to 3I minus 5J plus 7K, all in meter. Find 3 times vector A, the B part, vector A minus vector B, and the C part that we have to find the modulus of 3 times A. So how do we go about that? Remember, we are looking for magnitude of vector A. So solution, the first one, 3 times vector A. So what is vector A? Look at it, 2I plus 4J minus K. So all we need to do is to open the bracket, 6I plus 3 times 4, 12J minus 3K. So this is what we are expected to do, 3 times vector A. Is it difficult? The second one, that we have to find what? Vector A minus vector B. So that will be equal to, what is vector A? 2I plus 4J minus K minus 3I minus 5J plus 7K. And the addition is done component Y. So this will be 2I minus 3J, 2 minus 3 plus 4 minus 5J, then plus minus minus k minus plus 7k. So what do we have? So it will be minus 1 minus 7. So from here, if we simplify, you have minus 1 times I will be minus I. This one plus 4 times minus minus. This will give us 9j. Then minus 1 minus 7 will give us minus 8k. So this is the answer here. So this is how we go about it. Is it difficult? Let's look at another example. Let's look at another example. Given two displacement d equal to 6i, two displacement d equal to 6i plus 3j minus k all in meter, and E equal to 4i minus 5j plus 8k in meter. Find the magnitude of the displacement. We have to find 2d minus E, and the second one, we have to find magnitude of E. So how do we solve it? How do we get the magnitude? To get the magnitude, solution, let the magnitude of the displacement be F. So we have F to be equal to 2d minus E. So from here, let's substitute and see. D is given as this. So 2 times 6i plus 3j minus k equal to E is given by this expression. 4i minus 5j plus 8k. Okay, let's open this bracket first. 12i plus 6j minus 2k. Are we together? Then minus 4i minus 5j plus 8k. So if we simplify this, we will have 12i minus 4i. It will be 8i. Then 6j minus minus will be plus. So 6j plus 5j will be plus 11j. Then minus 2k minus 8k will be minus 10k. Are we together? So from here, we are looking for magnitude of F and not F. So the magnitude of F will be equal to square root 8 square plus 11 square plus minus 10 square. So if we simplify this, we will have 17 meter as the magnitude. So anytime we say find magnitude, this is where we are looking at. Are we together? So if you simplify this, you have this value. So the magnitude of the displacement that we were asked to find, 2d minus E, is equal to 17m. Then the second question says we should find the magnitude of E. So this is E. I told us we are in the second part now. Magnitude of E, anytime we say magnitude, you simply express it in this form. So E is given by this expression. So the magnitude will be 4 square plus minus 5 square plus 8 square. And if you simplify this, you have 105. If you find the square root, you have 10.2. Is it difficult? No, I don't think it's difficult. So this is how we go about using the component of a vector, in unit vector instance of the unit vector, to find the magnitude of vector. Okay, the next thing we want to look at is vector multiplication. Vector multiplication. How do we multiply vectors? In terms of the unit vector is the next thing we are looking at. Vector multiplication. Okay, there are two ways that we can multiply vector multiplication. There are two ways that we can multiply vector. We have two kinds of product of vector. We have the scalar product, and we have the vector product. We shall be looking at each of them. Scalar product and vector product. These are the two kinds of vector multiplication. Let's look at each of them one after the other. Let's start with scalar product. The scalar product is also called the dot product. So we can say scalar or dot product. Scalar or what? Scalar or dot product. So the scalar or dot product of two vectors A and B is defined as vector A dot vector B equal to the magnitude of vector A, magnitude of vector B, cos theta. Please, this formula is very important. According to scalar or dot product of vector, we say that if we have two vectors A and B, that the scalar or dot product is defined as vector A dot vector B equal to the magnitude of vector A times magnitude of vector B cos theta. So please, this formula is very important. Let's call it equation 1 as we make progress. Okay. Then there are some things we need to bear in mind about the angle, the theta. So the scalar product of two vectors defined by this expression can be positive, can be negative, and it can be 0. We shall be looking at it depending on the angle between them. So the scalar product of two vectors defined by this expression can be positive, negative, or 0, depending on the angle between them. So if the angle theta, if angle theta is between 0 degree and 90 degree, then the scalar product is positive. So what are we saying? That if you have two vector A and vector B, if the angle between them is, if the angle is between 0 and 90, then the scalar product A dot B is positive. When you do your computation at the end of the day, the answer will be positive. And if it is between 90, another condition now, 90 and 180 degrees, then the scalar product will be negative. So we are saying that if the angle is between 90 degrees, that is this theta, which is between 90 degrees and 180. If you compute A and B, the scalar product, it will be negative. And if it is equal to 90 degrees, if theta equal to 90 degrees, then the scalar product A dot B will be equal to 0. All this condition is very good. We take note of them. If the angle is between 0 and 90, when you compute this, is positive. If the angle is between 90 and 180, if the scalar product will be negative. And if it is equal to 90, the scalar product will be equal to 0. So please, we need to take note of all this as we make progress. Okay, another thing we need to remember, there are some rules we need to remember as it pertains to scalar or dot product. So we need to remember the following rules, that I dot j is equal to I dot k and is equal to j dot k and is equal to 0. This is the first rule. Then the second one is I dot I equal to j dot j equal to k dot k and is equal to 0. So with these two rules, we can carry out scalar or dot product. We can carry the multiplication of two or more vectors using scalar or dot product. This rule, like I said, is very, very important. Okay, let's solve some example to actually see what we are talking about. Example, if vector A is equal to 2i plus 3j minus 3k, and vector B is equal to I minus 2j plus 4k. Find, the first thing we have to find, A dot B, the scalar product. The second thing, the magnitude of A, and the magnitude of B, So these are the two things we are to find. Okay. Then also the angle between the two vectors, angle between A and B. So our question is set. Let's see how we go about it. So we are to find the first one, the scalar product of A dot B. So A dot B will be equal to, what is A? This is A, 2i plus 3j minus 3k dot I minus 2j plus 4k. Remember to put the caret on it. Okay, so applying this rule, we say I dot j equal to I dot k equal to j dot k equal to 0, and I dot I equal to j dot j equal to k dot k equal to 1. Please, sorry, this should be 1. Sorry for that. So if we apply that, 2 dot, we have this, plus 3 times 2, 3 times minus 2, j dot j plus minus 3 times 4, k dot k. Every other thing will be 0 based on this rule. So from here, and we have said that I dot I, j dot j, k dot j is equal to, so here we have 2, 3 times minus 2 will be minus 6, and minus 3 times 4 will be minus 12. So the scalar product of A dot B will be equal to 2 minus 6 minus 12, which will be equal to minus 16. Is it difficult? So this is how we get the scalar product of two vectors. Okay, so let's proceed. The next thing, we have to find the magnitude of A. So we are looking for magnitude of A, and that will be equal to what? This is A, will be 2 square plus 3 square plus minus 3 square, or square root. So if you simplify that, you will have square root of 22, and if you simplify, you have 4.67. I hope that is not difficult. So the next thing we have to find, the magnitude of B. Remember, I told us anytime say magnitude, this is the value for B, is 1 square plus minus 2 square plus 4 square. So if you simplify that, you will have square root of 21, which will give 4.58. So this is the expression for scalar product, and from here we have gotten this. We have gotten this magnitude. We have gotten this B. The next question says we should find the angle between them. So this is the angle. From here, this is the D, cos theta. We are using this expression. So from here, making cos theta the subject formula, we will have A dot B over magnitude of A, magnitude of B. So that will be equal to, we have gotten A dot B to be minus 16. Magnitude of A is 4.67 times magnitude of B, 4.58. So if we simplify this, we will have theta to be equal to cos inverse. Remember, we are looking for theta and not theta inverse. Cos inverse minus 0.175. And if you simplify, you have 100 degree. So this is the value that we have for theta. So from the equation, we have to find the scalar product, the magnitude of the scalar product, which we have gotten here. I hope you see the procedure, the process. Okay, then the magnitude of A, look at magnitude of A, see how we got the answer. Then the magnitude of B, look at it, see how we express it. Then the next question, the angle between. Using this expression, this is the angle we are looking for. So we simplify, and at the end we have it to be 100. Are we together? So this is how we solve, we use the scalar product to find the magnitude of the scalar product. Okay, let's look at another example of how we use the scalar product. The second one, if vector x is equal to I plus 2j minus 3k, and vector y is equal to 2I minus 3j plus 4k, find the scalar product, find the magnitude of x, the magnitude of x, magnitude of y, and also the angle between. The angle. I hope you can find this. It's the same approach that we will be using. So if you follow that approach, you can do that. Okay, let me give you the answer to guide you. The scalar product here, if you do it very well, you will have minus 16 as the scalar product. The magnitude of vector x will be 3.74, and the magnitude of vector y will be 5.38, and angle theta will be 37.32 degrees. So it's not difficult. You follow it, then simplify, you will get this answer. Okay, let's go to the next one, the vector, the vector product. The vector product. Yeah, we want to look at the vector product. It's the second types of vector multiplication. Vector product is also called cross product. It's also called what? Cross product. So we can say vector product or cross product. So the vector product of two vectors, A cross B, is equal to the magnitude of A, magnitude of B, sine theta. Please, this formula is very, very important. So the vector product of two vectors is given by this expression. Let's call it equation 2. This is equation 2. And here, let's look at the condition. If theta, this theta, if it is equal to 0, then vector A cross vector B is equal to 0. And this implies that they are parallel to each other. They are parallel to each other. Then the second condition, if it is equal to 90 degrees, then A cross B is equal to magnitude of A, magnitude of B. And this implies that they are perpendicular. They are perpendicular to each other. So this is the condition that two vectors may be parallel to each other, vector A, vector B, or they may be perpendicular to each other, vector A and vector B. Are we together? So this is the condition of the angle. And like we have the rule in a scalar or vector product, we also have similar rules in vector or cross product. Let's look at the rules. The rules is that if you have I cross I is equal to J cross J and is equal to K cross K, which is equal to 0. That is the first rule. The second one, I cross J is equal to K and J cross I is equal to minus K. The third one, J cross K is equal to I and K cross J is equal to minus I. The last one, K cross I is equal to J and I cross K is equal to minus J. So please, we must remember this rule, as this rule we shall be using it in cross product. Okay, let's look at example. Example, what is the product of vector A? Example, vector A is equal to 2I plus 3J minus 3K, and vector B is equal to I minus 2J plus 4K. Remember to put the caret sign to indicate that it is a unit vector. So solution, we are looking at vector A cross vector B. We'll write it, this is how we go about it. Write it in terms of modulus, terms of the unit vector. So if we look at this I, J, and K. So under I, we have 2. We have 2, 3, minus 3. And under here, we have 1, minus 2, 4. So here we can express it 3 minus 3 minus 2, 4. This one is in terms of the I component, plus 2 minus 3, 1, 4. Terms of J component, plus 2, 3, 1 minus 2 in terms of K component. This is how we do it. If you are taking this, the I component, you strike this, you'll be left with what? 3 minus 3 minus 2 and 4. That is what we have here. Then you come to J, you strike this, you'll be left with this and with this. Then when you come to K, you strike this, you'll be left with what? This. So that is the approach that we use here. And from here, if you open the bracket, multiply this times this minus this times this. That is how we go about with the multiplication. Let's do it together. Let's do it together. From here, if you multiply, you'll be having 3 times 4 minus minus 2 times minus 3. So we are through with the one in terms of I plus we are the one for j now. It will be 2 times 4, 8 minus minus 3. This is the one for j plus 2 times minus 2 minus 4 minus 3 for k. So if you simplify this, you will have 12 minus 6i plus 8 plus 3j plus minus 4 minus 3k. So if you simplify this, you have 6i plus 11j minus 7k. So this is the cross product of vector A times vector B. So the approach is somehow different from the one in case of the scalar or dot product. So with this idea, you have idea about unit vector. Unit vector. From here, to determine the magnitude of the unit vector, we have looked at it, and also the multiplication. And in the multiplication, we say we have two types, the scalar or what? Dot product, and the vector or cross product. And the rules involved, I've itemized it. Thank you very much for watching. Please like, share, and subscribe to my channel for more interesting videos. Bye for now.